Good day, ladies and gentlemen. I'm Wisnu from Binus University and University of Indonesia. I would like to present a research conducted with my research partners, Dr. Lin from University of Indonesia and Dr. Nina from Binus University. The research was about the impact of canyon pace direction on microclimate and thermal comfort in hot and humid Balikpapan city. This paper is based on simulation using Antimed software to figure out the microclimate and thermal comfort condition in two different building canyon settings. Balikpapan City is located close to the equator, so that it is important to consider these findings to strategies the building configurations for a more climatically responsive urban planning in the hot and humid context. Microclimate is a climatic condition in a certain area with an altitude close to the ground surface, which consists of several elements including temperature, wind speed, humidity, and others that influences thermal comfort for the surrounding populations. And the ICACE 3.1 software is software that is used to analyze the interaction between a development plan and the microclimate on a small scale in an area in order to produce recommendations for the thermal comfort generated in the development plan. This map shows the location of Balikpapan cities is close to the equator and could represent the hot and humid city climate context, especially where the planned new capital of Indonesia will take place, IKN, in East Kalimantan. So this table shows the setting and configurations used in this research, as we had conducted 5 sequences of process conducted in this study. The first is determining the building site configuration combined with the microclimate configuration set on September 18, 2021 from 12 a.m. to 12 a.m. and the next day in Balikpapan City. Second, modeling the building site configuration. The third, conduct simulation using the data on building site configuration and microclimate that have been obtained with the height of the receptor at the average height of the Indonesian populations, and the location of the receptor in the center of the building site. The simulations was conducted by comparing the condition of the microclimate in the direction of the canyon north-south and east-west, which were set according to the source of the solar radiation. Fourth, comparing thermal comfort is also done on the orientation of the north-south and east-west canyon. Fifth, simulate the thermal comfort with Leonardo image modeling. The entire simulation was conducted in the study using ICACE 3.1 software. So as we can all see the 3 pictures here, these are results of observation on the comparison of microclimate conditions in both canyons orientations. Wind speed at the receptor point at 12 a.m. to 12 p.m. the next day, to 12 a.m. the next day in the north-south canyon orientations is higher, 1.6 meter per second to 1.7 meter per second, than the east-west canyon orientations, 0.1 meter per second to 0.3 meter per second. This is influenced by wind directions conditions originating from the south, so that in the north-south opening, the wind will blow directly to the receptor point, unlike in the east-west opening, which was blocked by the building. Relative humidity, or QREL, from 12 a.m. to 12 a.m. During 24 hours in the north-south canyon orientations, 74% to 88%, tends to be higher than the east-west orientation, which is 70% to 85%, although not significantly. The temperature at both canyon orientation was not significantly different. However, the last picture on the bottom illustrates that the temperature in the north-south canyon orientation receptor point from 12 a.m. to 7 a.m. and from 3 p.m. to 12 a.m. is lower than that of the east-west canyon orientations, while during the day, from 9 a.m. to 2 p.m., the north-south canyon orientations has a higher temperature than the east-west canyon orientation. The situations is related to the process of sunrise and sunset, so that east-west openings tend to have higher temperature in the morning when the sun is in the east, and in the afternoon when the sun is in the west. In the north-south canyon orientation at that hour, sunlight will be blocked by the building, causing the temperature in the north-south canyon orientation in the morning and afternoon to be lower, while temperature during the day in both orientations tends to be the same due to the position of the sun, which is right above, so that heat rays go directly to the receptor, not blocked by the building. The results show that the influence of building orientation is not too significant in influencing the microclimate, but it also needs to be followed by other building design configurations, such as setting the height of the building and setting the height width ratio of opening based on the temperature comparison between the north-south and east-west canyon orientations, which is not too significant. It shows that the building height of 10 meters is still insufficient to create a shading area. And observing the temperature and thermal comfort temperature in both orientations of the canyon, the following results were obtained. Temperature fluctuates more than thermal comfort. The comparison between temperature and thermal comfort tends to be directly proportional at 1 a.m. to 7 a.m. and at 6 p.m. to 12 a.m. The drastic fluctuation of thermal comfort occurs in the range from 9 a.m. to 5 p.m. does not occur with the temperature. An inverse comparison between temperature and thermal comfort occurs from 9 a.m. to 12 p.m. The result shows the change in the thermal comfort are not solely influenced by the temperature, but there are other microclimate factors that influence it. To explain this, the data in the upcoming table can be used as a reference. So the north-south canyon orientations has better thermal comfort than the east-west canyon orientations. This is partly due to the higher wind speed conditions in the north-south canyon orientations compared to the east-west canyon orientation. So the X factor is the wind speed. So these figures show thermal comfort for north-south canyon direction under overall site conditions taken at 10 a.m. and at 2 p.m. respectively. In general, the north-south canyon direction shows a lower thermal comfort than the east-west. The highest thermal comfort occurs at 2 p.m. in the east-west canyon directions, represented in red in the central area of the site between the two buildings. Meanwhile, the lowest thermal comfort occurs at 10 a.m. at the north-south canyon direction, represented in orange, with a hint of red and slight orange color in the middle area of the site between the two buildings. For the concrete pavement area, colored in fuchsia, around the buildings, the thermal comfort is relatively at the same level in all scenarios, which is the area of the site with the highest thermal comfort compared to other areas of the site. Similar results were obtained in the temperature in the north-south canyon directions. You can see in the two pictures on the right side, where in general, the north-south canyon direction shows areas with the viewer pink and red colors to represent the two highest temperature levels. This is influenced by the orientations of the north-south building with a better potential to block sunlight at 10 a.m. and 2 p.m. And the north-south opening allows the wind to blow without being blocked by the building. So from this method of research, from the research that we have conducted, we conclude that there is a mutually influencing relationship between the canyon orientation, microclimate conditions, and thermal comfort. The increase in the temperature is not always followed by an increase in the thermal comfort, but other microclimate factors influence the wind speed and relative humidity, geographical location, and the position of the sun. North-South Canyon orientation is more recommended to increase the thermal comfort in Balikpapan City. However, the selection of canyon orientation also needs to be followed by the physical configuration of the building. The addition of vegetation needs to be done around the building area because the vegetation has function of filtering radiant heat and increasing thermal comfort in the area. And we recommend that to increase the number of water bodies and vegetation in the form of providing green open space, adjusting the height with ratio of the openings, regulate the design or architecture of the buildings, and also adjust the orientation of the canyon. So that's pretty much that we can conclude from our research, and we can recommend from our research. Thank you for your attention.